Hello, my name is Robin Goad and I'm president of Fortune Minerals Limited. This is a video flyby of the company's planned hydrometallurgical facility about 26 kilometers northwest of the city of Saskatoon, Saskatchewan, near the town of Langham, shown here. The proposed facility is called the Saskatchewan Metals Processing Plant, or SMPP, and will process NICO concentrates to high-value metal products. The SMPP straddles the Canadian National Railway near the Trans-Canada Highway between Saskatoon and Edmonton, Alberta. It's close to natural gas lines, the Saskatchewan electrical grid, a significant educated labor pool, and sources of lime and other reagents. This is the facility which shows the main process building, the warehousing facilities to the right side, the oxygen plant and electrical power sources, as well as the cobalt and bismuth processing facilities, forming a U around the ponds for recycled water, for processed water. The square gridded area you see in the foreground is our residue storage area. This is essentially the residues, process residues are covered with earth and revegetated for reclamation. The main process building is serviced by rail for concentrate delivery at the southeast end of the facility. That's what in the foreground now. Silos are situated along the rail siding for delivery and storage of reagents such as lime and soda ash. On the left side of the screen now, you'll see the oxygen plant, the electrical substations and power supply. And as we circle around now, you'll see the main copper and cobalt process facility. We're now circling past that facility, and you'll see the bismuth process plant. The white area here are our processed water storage ponds. And this is the office and warehousing complex. We're now looking at concentrates stored outside the process plant as we enter into the building. As we enter the southeast end of the main process building, you can see tanks to repulp the NICO bulk concentrate, as well as the regrind mills and cyclones that will prepare the concentrate for secondary flotation. Flotation cells are located on the upper decks, where the bulk concentrate is separated into gold-bearing cobalt and bismuth concentrates. We're now passing the autoclave, where we process the cobalt concentrate and dissolve cobalt using pressure acid leach, and the cobalt goes into solution. As we exit the autoclave, there are a number of tanks where we go through selective neutralization to strip out metal impurities, including iron and arsenic and copper, and that copper is subsequently relocated or recovered in the cobalt process building. We're now looking at the ion exchange area, where we remove other metal impurities, including nickel and zinc. And as we exit the building, you can see the oxygen plant again, the electrical substations and power supply, as we are about to enter the cobalt and copper process building. This particular flow sheet is designed to produce cobalt metal and 99.8% or 9% cobalt cathode material, as well as a copper precipitate. We also have a solvent extraction setup for the production of a cobalt sulfate heptahydrate, which is used in the batteries. This is air exchangers, basically to clean the air within the building. We're now viewing the water treatment plant. We have reverse osmosis as well as chemical treatment to purify the water and recycle a large portion of the water back into the process plant so that we minimize our intake of fresh water. We're now looking at the back end of the gold plant. Gold is recovered by cyanidation of the leach residue from the autoclave. It undergoes a Merrill-Crowe process, and then is smelted into doré bars. And that's the completion of our video.